This video is going to be a continuation of the last video regarding the internal rate of return method for evaluating projects. Now, what we learned last time was that the internal rate of return was the interest rate that was necessary to make the present worth of a series of cash flows equal to zero. Now, the series of cash flows had an exponential term in them when calculating the internal rate of return. And as you may recall from one of your math classes, if there's one sign change in the series of cash flows, then there's only one solution to the problem. For example, when you have a cash flow with a series, let's say negative in time period 0 and the rest are positive, that's one sign change. There's only one solution to the problem. If you have a series of cash flows where there's a negative cash flow in period 0, perhaps a positive cash flow in periods 1 through n-1, and perhaps a large cost in the last time period, n, so that it's negative, you've had two sign changes. And potentially when there are multiple sign changes, there are multiple routes to the equation. There are multiple solutions to the internal rate of return. And so what I'm going to do now is I'm going to try to address with you how these kind of issues are dealt with in industry. So I'm going to talk about what to do, talk about projects, and then talk about a new animal called the modified internal rate of return. So I want you to understand why multiple solutions for internal rates of return can occur, identify them if they exist, and whether they are an issue or if they're not an issue, and then how we can use the modified internal rate of return function to potentially solve this problem. So let's look at an example where we have land is going to be strip mined for coal. Now this doesn't have to be coal. This can be lithium. But the land costs $610,000. It's going to generate income for 10 years, and then it's going to be, the land is going to be restored to its original value after the 10th year, but it's going to cost $1.5 million. So the question is this a desirable project? So what I want to show you here is I want to show you a method for looking at this. So let's cut this and we'll go out into look at these new numbers. And so what we have here is end of year and cash flow. It's going to go from 0 through 10. And so we have an initial expense of negative 610. And we have ten periods of 200. But in the 10th period, we also have an abandonment expense or a restoration expense of $1.5 million. Oops. 200. So what we can do here is there's several things we can do. But one of the things we can do is we can first calculate the internal rate of return. And it's 4%. Okay, but as I just mentioned earlier, because we have two sign changes, we have negative to positive to negative, we potentially have two solutions to the equation. The present worth equals the sum of cash flow T divided by 1 plus I to the T. How about if I do this a little bit differently? I'm going to make this superscript, and I'm going to make that a superscript. And this present worth, this sum should be a sigma, so it's all of the cash flows. That should be a subscript, I'm sorry, cash flow sub T. And this also equals 0 equals. So this is the definition right here, and this is a solution. There's potentially another solution for I because there's two sign changes. How do we get that? Well, I think one of the best things to do is to actually search for it. And how do we search for it? Well, I think, and you're never going to do this in a presentation, but you're going to do this in preparation for a presentation. So let's just look what our interest rate, and I think it's at a 10% interest in the problem. And so we can look at the present worth of the cash flow. Equals that. Now I'm going to do it in one step. 1 plus function f4 close raised to the 0 power. So I'm not multiplying, I'm doing it all in one step. So this is going to have a positive present worth. We can see that, and I'll just show you that in just a second here. It's got a positive present worth of 10%. So fundamentally, it's a good project, positive present worth of 10%. But if our interest rate is 10%, it has an internal rate of return of 4%. Well, that's less. If this is our marginal rate of return, this 4% is less. That's saying it's not a good project. So what do we have? Well, I think the best thing to do is to plot the present worth as a function of interest rate. Now, what we can do here is, let's say we want, and let's do it from negative 20%, and I'll explain that in just a second, all the way up to 50% in increments of 10%. So what we want to do is and I'm going to show you how to do a data table right now. And so data tables are very, very useful in, data tables are very, very useful in plotting and running a calculation for plotting. So what we want to do is we want to calculate this present worth as a function of interest rate. Okay, so I can do it at minus, let me just pop in minus 20%. And I get negative 622. 6.67. Let me pop it in at negative 10%. I get negative 1176. At 0%, I get negative 110. Now, kind of as a sanity check, 0% is just the sum of the undiscounted cash flow, so I can just see if that works. So this is kind of a brute force method. It's kind of a pain. So let me show you, if you're not familiar, how to do a single variable data table. Now later on in the quarter I'm going to show you how to do a multiple variable or a two variable data table. So when you do a data table, these are the variables you want to change. And that's basically our interest rate. And one row above the first variable, we're going to look at our performance variable. That is our present value. That's our performance variable. Now what I'm going to do now is I'm going to highlight this table. So this is the calculated number that's calculated at this value right here. And these are the numbers I want to vary. And I'm going to go into the Data tab, What If Analysis, Data Table. I don't have this is a one variable data table. I don't have a row input cell, I have a column input cell. And my column input cell is this number right here. Click OK, and look what has happened. I have populated this okay, so I populated this. We got this. This is the value at negative 20%. This is the value at negative 10%. This is the value at 10%. Remember when we popped 10% in there, we got a value of 40.6. So now what I've done, and so this is a shortcut to populate this table. I'm going to delete these. This was just to show you what they were, that this has actually calculated it properly. What I want to do is I want to build a chart from this information. I just want to plot, this is my X variable, this is my Y variable. So what we want to do is put in a chart that plots the present worth, that's this column right here, as a function of the interest rate. So we have the formula right here. We've already populated our data table. Let's go into the charts. Let's insert a scatter chart. And this is not that informative because the range of the negatives is so much larger than the range of the positives. So let's move this chart off to the side and let's insert another chart. Let's just do it from 0% on. So we're going to insert chart, scatter chart, and what we have is we have a chart that crosses the x-axis at the 4%, crosses the x-axis at 18%. How did I get 18% with the IRR function? With the IRR function, and I sort of glossed over this, you have a starting point, and it's a heuristic algorithm, and it will look, if you don't put anything under guess, it will start at 0% and probably find, I say probably, likely find the value closest to 0%. That was 4%. If we give it a starting point, let's say 15%, it'll start looking at 15% and it finds the other solution. Now, it doesn't always work. You can give it multiple points. It may never find another solution. It may only find one solution. There's not a good answer to finding multiple routes. It's trial and error. That's why I was saying you never show this process to management. You go through this and have all the answers prior to presenting a project justification. But what this thing tells us is that between 4% and 18%, we have a positive present value. Now, in theory, that should mean it's a good project. Positive present value at 10%, if 10% was our hurdle rate. However, this is a big deal. If we just ran this thing without the starting point, we'd find the IRR is 4%. That's less than our minimum rate of return of 10%. It's not a good project. What do we do? Well, I'll get to that, but this is a messy problem and the answers are not always clean. So here is the graph of what I showed you starting at 0%. That's the first step. So cash flows with multiple solutions, you can have multiple routes. They may not fit a typical investment patterns and they may give you multiple routes, but they don't always give you multiple routes. So what do? You graph the present worth over the interest rate range from -100 to 100%. If there's only one route, you probably have a valid internal rate of return. If you have more than one route, if one of them is less than 0, you can usually ignore that and only evaluate the route that's greater than 0. If you have double positive routes, like the example I just showed you, then both the internal rate of return and present worth are unreliable, and we have to go to a different step, which most senior managements are not familiar with. I'll get to that before the end of this video. Now, the most common cause of multiple sign changes is a salvage cost. And if the salvage cost is very large, then you can have two routes that are greater than 0 and neither is useful. Now let's look at this example here. We have a project with a salvage cost. It's not an unreasonably large salvage cost, right? It's not greater than the initial investment. I've worked for an energy firm most of my career, or different energy firms. We're going through abandonment of wells. Abandonment of wells now can cost multiples of what it cost to drill the well. So let's have a look at this. Now I've already put a little bit of this into Excel. So here is the cash flow stream. Let's look at the present worth of the cash flow stream. So we're going to use P equals F over 1 plus I to the end. I'm embedding it into the formula. And I show that the present worth is 1.8. The internal rate of return of this cash flow stream, the closest one is about 10%. I think it's slightly above 10%. But we have two sign changes, so we could have two routes. So let's plot this over the range of -100% to +100%. So -100%, and I'm going to do increments of 20%. And what we want to do is we want to plot the present worth, and we're going to generate a data table. Now, the formula 1 over 1 plus I to the n, we need to remember if we have minus 100%, it's going to be 0 in the denominator, so we can't do that. Now let's generate the data table. So we go into data, what if analysis, data table. It's a single variable data table, so we're just going to change the interest rate. And this is what we have. Now if we look at this, we can see it's hugely negative at minus 80%, hugely negative at minus 60%. At minus 40, it gets to be slightly negative. So let's graph this range right here. And what we have is we have a graph that looks like this. So it crosses at around negative, what, 30%, 35%, peaks out, and then crosses again at the 1.8%. I'm sorry, the 10.5%. So the interpretation of this is that this can be ignored. It's in the negative value range. This is the relevant range, and the 10.5% is a reliable internal rate of return. Now let's just do one more internal rate of return here. So we're going to do this internal rate of return, but we're going to start at minus 50%. And we come up with a value. The second root is minus 38.3%. It's not relevant, therefore we can ignore this. Not every problem is going to be like this. Now we can look at another problem that's going to be exactly the same. We have this series of cash flows. We have potentially two roots to this equation. So basically we drill a well, an infill drilling well. It accelerates production. So incrementally we make more money sooner at the cost of making less money later. Now this question is how many roots for the present worth equation? Potentially two. Is one a useful root? Should the project be funded? What we need to do is we need to plot the present worth over time. And this is what it looks like. It has two positive roots, and so the present worth doesn't look like it's going to be a useful formula. So this is one of those really messy problems. And then what do you do? Because it's got two positive roots. What do you do? Okay, we're going to get to that again. Now here's another example. We've got one sign change, a second sign change, and a third sign change. Now this could happen if you have, this shows an expansion in the fifth year. We have potentially 1, 2, 3. We got three sign changes. 1, 2, 3 sign changes. Potentially 3 roots to this equation. Is it one useful, and what's the recommendation? Well, what we need to do is plot this series of cash flows as a function of interest rate. And if we did that, this is what it looks like. We've got one positive root at 21%, and therefore it's an attractive project. Now, they don't always work out this way. So there's an animal called the external rate of return. It's used when there are multiple routes to a cash flow problem. What you do is you compute the present worth of the costs using the minimum rate of return and the future worth of the benefits. You calculate the IRR of these two. That is called the external rate of return. If the external rate of return is greater than the minimum rate of return, it's a good project. If the external rate of return is less than the minimum rate of return, it's a bad project. So let's go back. I want to show you an example from what we've just done. So let's go back and look at this project right here. So we're going to copy this. And our minimum rate of return, our interest rate, is 10%. So let's expand this a little bit. If we expand this one, if you recall, we had 200,000 positive, 1,500 negative. So let's expand this just a little bit. So we have our negative cash flows and our positive cash flows. And that's going to equal this, and this is going to equal negative 1,500. And the positive cash flows are all going to be 200. Okay, so the present worth of the negative cash flows. And that's going to be this divided by 1 plus the interest rate raised to that exponent. So the present worth of 1,500 at 10% is this. The present worth of the positive cash flows. I'm sorry, the future worth of the positive cash flows. Okay, so this is going to be the future worth at the end of the 10th year. So it's going to equal this times 1 plus I raised to the 10 minus n. You can verify that yourself. Let's move that decimal point over 1. So this should be 220. It is. And we take this all the way here. So if we sum this up, the present worth of all the negatives, we get negative 1188.31. If we sum up all the future worth of all the positives, we get 3187. So now let's look at our ERR calc. So this is going to be time period 0 is right there. And time period 10 is this number right here. And then we need to insert all these zeros, because if we don't, we're going to have an error. Now, so this is our modified external rate of return, modified cash flows, the present worth of all the negatives, the future worth of all the positives. You could operate off of this right here and ignore the 200 in the 10th year. This is more the more accurate way to do it. So the external rate of return is going to equal, you do the IRR on this. It equals 10.4%. That tells me that this is a good project. It's worth doing. The concept is we are going to be investing these 200s in projects that are going to be returning 10%. That's going to be more than enough to cover that initial cost and this final salvage expense. Okay, what I've done in the last couple of slides here is I've taken you through a few examples. So I'm doing exactly what I just showed, where we have an investment with benefits, costs, and a net cash flow. And it shows you that you can actually do an external rate of return on a well-behaved cash flow with just one sign change. So if our minimum rate of return was 10%, the internal rate of return is 21%. That says this is a good project. The external rate of return is 13%. That's greater than 10%. It's still a good project. So recognize I'm treating my costs separately. That's why the present worth of the costs is not just $1 million. Now this is a homework problem you're going to have in the next week, and it's just going to show you a way to attack that problem. So the takeaway from this this lecture, because I've got, I want to cover one other point here. There's something called the modified internal rate of return, and it's it incorporates the two external rates of return, and it requires a rate for investing and a rate for borrowing, and that will give you the modified internal rate of return. If you use the same rate for investing and borrowing, and that's your minimum rate of return, the modified internal rate of return function will be the same as the external rate of return calculation. That's a lot to grasp right here. So I showed you a method for calculating the external rate of return. If you want to do a shortcut, you can use the modified internal rate of return function using the same value for the parameters for the rate for investing and the rate for financing. And this basically shows you the math behind the modified internal rate of return. And then this will take you through the example before, where in this one actually, this is the example 3, where it was the oil well with the accelerated production. And what we're going to do is calculate not the external rate of return, but the modified internal rate of return. And What's in here is in this, we have a different financing rate from investing rate. The investing rate always has to be higher than the financing rate, otherwise the company can never make any money. Okay, so let's take a step back and think about what we're talking about in this video. In this video, I've been covering what I would call cash flows that are not well behaved. We've got multiple sign changes. Multiple sign changes are always messy. The first thing I would do when I see a multiple sign change in a project I'm analyzing is plot the present worth over a range of -80% to positive 100%, just to see what the present worth function looks like as a function of interest rate, and then see if I really have a mess. If I really have a mess, the mess being I have multiple positive roots, using the external rate of return / modified internal rate of return is a potential solution. Most CFOs, most senior management will not have a clue about external rate of return or modified internal rate of return. So you need to be very, very cautious if you want to show this to senior management, because they may not have any idea of what you're doing and some of the theory behind it. I'm just touching on the calculations. I go through the theory behind this in the graduate class in engineering economics. So recognize that you just need to be cautious if you have multiple sign changes. And I think the first step you want to do is plot the present worth as a function of interest rate. That's all for these unusual cash flows. I think you're going to see a little bit of it in the homework, and you can address me privately if you need to, if there's other questions on this.